Hello, my name is Dr. Dan Wedding, and this is DrWedding VB22E. VB controlling a Picaxe microcontroller using a USB to TTL UART. Most of the viewers who watched my VB22 video did so in order to communicate with an Arduino, Picaxe, or some other microcontroller. Now that I have covered the VB code, I have included these 7 bonus videos to help you get started working with the COM ports. Please review the video that matches your hardware. These videos will have 4 parts. There will be a diagram of the hardware configuration with a parts list under it, and there will be a brief description of the hardware. There's a copy of the firmware that is used to program the microcontroller, and there will be a brief explanation of the firmware. There's a copy of the Visual Basic code that will be used to open the port and control the circuit. To learn more about the VB code, please watch DrWedding VB22. A working demonstration is shown at the end of the video. A diagram of the circuit is shown below. The 4 LEDs are connected to pins 0 through 3 on port C. The keypad is connected to all 8 pins on port B. Pins B0 through B3 are input pins, and B4 through B7 are output pins. The USB to TTL UART board has power and ground connected and 2 signal pins. The transmit pin of the TTL UART board is connected to the receive pin of the Picaxe, and the transmit pin of the Picaxe is connected to the receive pin of the TTL UART. Note: the transmit of one device should connect to the receive pin of the other device. However, some parts I have ordered have had the RxD and TXD silkscreen labels reversed on the device. You may need to swap these wires if your device does not work. The Picaxe code will receive the data from VB and toggle the selected LEDs. It will also transmit the value on the keypad to VB when a button is pressed. This section of code will create 2 variables: key value to hold the ASCII character printed on the keypad, and once to act as a Boolean to limit the number of times the character is sent to VB. The next section assigns the pins as inputs or outputs and sets them to their default values. The last part sets up the internal UART of the Picaxe. The hardware serial pointer points to the memory location where the next input character will be stored. The hardware serial input flag is 0. When a character is received, it is set to 1. The byte B10 is used to hold the character that was received from VB. The main loop is doing 2 jobs. It checks the keypad to see if a button was pressed. If a button was pressed, the character is transmitted to VB. Then, the main checks to see if anything was received from VB. If a character was received, the hardware serial in flag is set to 1. If a character was received from VB, it is retrieved from the scratch pad and put in B10. Then, the subroutine mail call is called to parse the data. The subroutine mail call will run the character through an if block that will toggle the selected LED. After the if block is complete, the hardware UART is reset so the next character can be received. The scan keypad subroutine sets the variable key value to null. Then it sets the pin connected to the first column to ground. Then the 4 rows are looked at one at a time. If the row is high, the button is not pressed. If the row is low, the button is pressed and key value is set to the value printed on the button. This is repeated for the second column, and the third column, and the fourth column. Because the microcontroller runs at 8 MHz, it will run this subroutine multiple times per second. You only want the character to be sent to VB one time per press. This if block will transmit the character once, then ignore the key press until the human lifts their finger off the button. Then the if resets to send the next character. The Visual Basic code used in this demonstration is an updated version of the code found in VB22. Below is the form and the names of the objects used in the VB code. A text version of the code associated with this form is found in the description below. The form and the code were explained in DrWedding VB22. The program in this link has a few minor updates from the version in that video. Some of these updates include: phones that are plugged into the computer will not appear on the combo box. A refresh button has been added, so COM ports can be added to the system while the program is running. If no COM port is found, the connect button is not visible. The if serial port 1 is open if block was moved to the top of the button connect subroutine. This allowed the program to select a new COM port while the program is running. This is useful when connecting to an HC05 Bluetooth module. A do while serial port 1 bytes to read is greater than 0 loop was added to the serial port 1 data received subroutine. This helps speed up and prevent lost characters when using an HC05 Bluetooth module. This demonstration will show you how to connect your Visual Basic project to a Picaxe 28x2 microcontroller using a USB to TTL UART board. First, I'm going to plug in the USB to TTL UART. Then I'm going to refresh the Visual Basic program so I can find the COM ports that are connected to the computer. Visual Basic found the cable on COM port 10. Now I can connect to COM port 10 to control the Picaxe with my Visual Basic code. I have 4 buttons, each one controlling one LED on the board. And I have a keypad that will send information on the button I am pressing up to Visual Basic and display it on the text box. Updating the text box does not cause an illegal cross-thread error. Hopefully, this video will give you a good idea on how to set up bidirectional communications between a Visual Basic program and a Picaxe 28x2 using a USB to TTL UART. If you find these videos useful, please like and subscribe. It is the only way I can continue to make these videos.